This example looks at a body fluid test kit, which in many respects is like the reagent test kit that we looked at previously. The product has 11 variants and it includes a test tube that is filled partly with a generic solid and partly with a chemical that's unique to each product variant. So the unique product variant chemicals comes in as a raw material which has to be pre-treated, and that pre-treated raw material is held as an intermediate stock. Likewise, the solid material is made as a separate process and the stock of that is held. So the main process starts with formulating the reagent, filling the test tube with the solid and the special reagent, testing it, calibrating it, packing it, and then putting it into a finished goods stock as if you were a distributor. Then the last process we've put in here is the shipment. So we have a truck that's taking those 11 variants out to the various customers on a regular basis. So from the model's point of view, response time is actually simply from that finished goods stock to the customer. So let's see what the operations model looks like. We have 860,000 items a year at a unit cost of about $1.70. And you'll notice that the batch related cost is very large compared to the volume related labor cost, indicating that this is very much a batch activity. We have response time of 32 days, which is something we might want to look at. So, having said that batch size is the main driver of cost here, that forces us to look at batch size to save money. So let's suppose instead of making every product every week, which would give rise to 572 batches a year, let's say we're going to make every product every 2 weeks. Let's see what effect that has. Well, as we imagine, that's more or less half the batch cost and not had too much effect anywhere else. It has changed the most used work center from formulations area to the pre-treat area, but neither of those are worrying in terms of utilization. So what else might we do? Well, let's just have a look at timing and inventory. We defined the finished goods stock by specifying here a non-zero number. When we do that, that forces the model to say there is a sawtooth type pattern to the way the stock behaves after that activity. And that effectively puts a stocking point in there, which means that the response time clock starts at that point and not sooner. So let's have a look at the truck. So what this means is that the response time and lead time is really purely down to the truck. So at the moment we have the truck leaving when it's full of product. So we have a batch size effectively of 1, which means a full truckload. Let's suppose we ship when the truck is only half full, which is effectively doubling the frequency. This has the effect of halving the response time. So that might be attractive. Clearly running the truck twice as often has doubled the cost of that, but that's still bearable. We still saved a lot more than it's costing us. It's changed the capacity utilization again now to the truck itself. So let's have a look at something completely different. Let's put this back to where it was. Check that we zeroed it. And now we're going to do something that is quite often happens, but manufacturing have little control over it. We're going to change the product mix slightly. Here's the 11 products. They have different sales volumes, different chemicals cost. Well, let's suppose product code K has been removed from the portfolio, and that 20,000 that was in there is now going to go as product F, so that 10,000 becomes 30,000. Total is still 860,000, but we have 10 variants now instead of 11. That has the effect of reducing batches because we have now fewer batches to make, 10 variants worth rather than 11 variants worth. It also takes some cost out because there's less product related expense, there's one less product to support, and it has the effect also of reducing the response time for the truck. We might want to do something more about the inventory, which is a little bit negative there. Well, let's take a look at some of the time which might be causing some of the work in progress. We have a 1-day hold time after testing. Suppose we could remove that. That puts work in progress at least to a positive situation. So there's some things we might do. The last example is where your manufacturing has to react to a change imposed on it from outside. That's not an uncommon situation. For your information, these examples are close to scenarios 34 and 35 of our book, Bridge of Faith for Operations.